Now, in this video, we will going to take up one more problem, the problem number 67. A metallic bar of 250 mm by 80 mm by 30 mm is subjected to a force of 20 kilonewton, which is tensile, and 30 kilonewton, which is again tensile, and 15 kilonewton, which is again tensile, as shown in this figure. Determine the change in volume of the block. Take E will be equal to 2 into 10 to the power of 5 Newton per mm square, and the Poisson's ratio as equal to 0.25. So here, 20 kilonewton is acting along the direction of x-axis, which is P1, which is 20, and 30 kilonewton is acting towards the y direction, which is P2 is equal to 30. Both are tensile. And similarly, 15 kilonewton is acting towards the z direction, which is P3. So we need to find out what is the change in volume of the block. So once you are considering stress in the direction of xx, which is sigma x, will be equal to load in the direction of xx, that is P1 by area of cross section perpendicular to the direction of P1. So that means here we have P1, which is load acting along the direction of the xx, and perpendicular to the direction which is area is 80 into 30. So that is the direction perpendicular to the direction of the application of load. That becomes the area, load by area of cross section. So once you are considering that, so that will be equal to 20 into 10 to the power of 3 divided by 80 into 30, which will be equal to, on simplification, you will going to get it as 8.3333 Newton per mm square, which is tensile. Similarly, stress in the direction of yy, which will be equal to sigma y, that is load in the direction of yy, which is P2 divided by area of cross section perpendicular to the direction of P2. So that means here you have, that is P2, which is 30 into 10 to the power of 3 divided by the area of cross section, which is perpendicular to that, which is 250 into 80. So on simplification, you will going to get 30 into 10 to the power of 3 by 250 into 80, which will be 1.5 Newton per mm square. Again, it is tensile. Similarly, stress in the direction of ZZ, which is sigma Z, will be equal to load in the direction of ZZ, which is P3 divided by area of cross section perpendicular to the direction of P3. So what is that? So load in the direction of ZZ, which is P3, which is 15 into 10 to the power of 3 divided by perpendicular to the direction, which is the lateral direction, which is 250 into 30. On simplification, you will going to get it as 2 Newton per mm square. Again, it is the tensile stress because the load applied is tensile load. Now, what is the original volume? See, original volume is V, which is equal to L into B into D, which is equal to 250 into 80 into 30. On simplification, you will going to get it as 6 into 10 to the power of 5 mm cube. So what is the volumetric strain? Volumetric strain is delta V by V, which is sigma x plus sigma y plus sigma z by E into 1 minus 2 by m. So delta V by V, you know the substitute value of V, which is 6 into 10 to the power of 5, which is equal to, you know the stresses in x, y and z direction, which is 8.3333 plus 1.5 plus 2 divided by 2 into 10 to the power of 5, which is E into 1 minus 2 by 2 into 1 by m is 0.5. So on simplification, the change in volume delta V will be equal to 17.75 mm cube, since it is the positive value. So therefore, you will going to have the increase in volume. So similarly, we will going to take up one more problem, which is on the problem number 68. A bar of 600 mm long is having a square section of size 50 mm by 50 mm. If the bar is subjected to an axial load of 120 kilonewton and lateral compression load of 600 kilonewton on faces of 50 by 600, find the change in size and the volume E and the volume. Take E will be equal to 2 into 10 to the power of 5 Newton per mm square, and the Poisson's ratio as 0.3. So here, if you see the value, this is the area of cross section, which is 50 by 50. And the length is 600 mm. Then if the bar is subjected to an axial load of 120 kilonewton, 120 kilonewton is the axial load which is applied here, and then the lateral compression, that is P2 which is 600 which is acting, and P3 which is 600 acting in this direction along the faces of 50 into 500 mm. So this is 50 into 600. So this is one face, and again this is 600 into 50 along the other direction, which is Z direction. Now find the changes in the sizes. So what is that? Stress in the direction of XX will be equal to load in the direction of XX, which is P1 by area of cross section perpendicular to the direction of P1. So if you are considering that P1 is 120 into 10 to the power of 3 divided by 50 into 50, we will going to get that value as 48 Newton per mm square. Then what is the stress in the direction of YY, which is sigma y will be equal to load in the direction of YY, which is P2 by area of cross section perpendicular to the direction of P2. So that will be equal to, that is 6 into 10 to the power of 5 because 600 kilonewton. So 6 into 10 to the power of 5 divided by area of cross section is 600 into 50. So that will be equal to 20 Newton per mm square. Since the load applied is compressive load, therefore the stress developed is the compressive stress. Similarly, stress in the direction of ZZ, which is sigma Z, will be equal to load in the direction of ZZ, which is P3 divided by area of cross section perpendicular to the direction of P3. So what is that? Again 600 into 10 to the power of 3 divided by 600 into 50. So on simplification, you will going to get it as 20 Newton per mm square. Again, it is compressive stress because the load applied is compressive load. What is the strain in the direction of Xx, which is epsilon x will be equal to sigma x by E plus 1 by m into E into sigma x plus sigma z. That is because sigma y and sigma z is positive negative. So minus into minus becomes positive. So that is the reason why you are getting the positive value here, even though it is compressive stress. If it is tensile stress here, then you are going to get negative here. So substitute the values. Epsilon x will be equal to sigma x is 48 by 2 into 10 to the power of 5 plus 1 by, that is 1 by m is 0.3 by E, which is 2 into 10 to the power of 5 into 20 plus 20. So on simplification, you will going to get it as 3 into 10 to the power of minus 4. So what is epsilon x? Also we know that epsilon x will be equal to delta L by L. You know epsilon x, which is 3 into 10 to the power of minus 4 is equal to delta L by 600. So on simplification, delta L will be equal to 0.18 mm. So what is the change in length? 0.18 mm increase. Strain in the direction of YY, which is epsilon y, will be equal to minus sigma y by E minus 1 by m into E into sigma x minus sigma z. So what is epsilon y? Because minus 20 by 2 into 10 to the power of 5 minus 0.3 by 2 into 10 to the power of 5 into sigma x, which is 48 minus 20. On simplification, you will going to get minus 1.42 into 10 to the power of minus 4. Also we know epsilon y is delta v by v. So that is minus 1.42 into 10 to the power of minus 4 into delta b, that is equal to delta b by 50. So on simplification, minus 7.1 into 10 to the power of minus 3 mm decrease. Similarly, strain in the direction of ZZ, which is epsilon z, will be equal to minus sigma x by m into E minus of minus sigma y by m into E plus of minus sigma z by E. So minus sigma x by m into E plus sigma y by m into E minus sigma x by E. So sigma x z by E minus of 1 by m into E of sigma x minus sigma z. So minus 20 by 2 into 10 to the power of 5 minus 0.3 into by 2 into 10 to the power of 5 into 48 minus 20, which is minus 1.42 into 10 to the power of minus 4. Also we know epsilon z will be equal to delta d by d. So minus 1.42 into 10 to the power of minus 4 equals delta d by 50. So change in depth will be minus 7.1 into 10 to the power of minus 3 mm. So that is 7.1 into 10 to the power of minus 3 mm, which is decrease. Therefore, what is the volumetric strain? Epsilon v will be equal to epsilon x plus epsilon y plus epsilon z, which is equal to 3 into 10 to the power of minus 4 minus 1.42 into 10 to the power of minus 4, again minus 1.42 into 10 to the power of minus 4. So on simplification, you will going to get 0.16 into 10 to the power of minus 4. Since also epsilon v will be equal to delta v by v, that is epsilon v, we have got the value as 0.16 into 10 to the power of minus 4 equals delta v by 600 into 50 into 50. So change in volume, delta v is 24 mm cube. Since it is a positive value, so therefore you will going to get it as increase in volume. So this is how you will be able to solve this particular problem. If you find this video is useful, please subscribe to my channel. Thank you very much.